Hey guys, welcome back. For week 3, we're going to continue and kind of wrap up the starting system. So we've already checked the battery for the first week. We watched how much it drew down whenever we started up and what it went up to when the battery started, or the alternator started charging the battery up. And then week 2, we measured the voltage drop of the positive and negative cable systems. So the only thing we haven't done was add in an accessory, and I was kind of waiting a couple weeks for the accessories because I don't want to overwhelm people and make them think they have to go out and buy a bunch of stuff to perform some of the testing. So if you don't have this accessory, you can do a lot of the other tests and determine what's wrong. But the next accessory we're going to use is a high amp clamp. Now this is a Fluke high amp clamp. It's the I410. I think it's like 1,000 amp clamp. I don't know how much it costs. This belongs to the shop. I have a Picoscope one as well, but this one has banana jacks on it, so I use it normally when I'm using the snap-on scanner. Now I do have the Picoscope and the snap-on scanner both connected this time, so I will get waveforms with both machines just so you guys can look at those, and if you're using one machine versus the other, I'm not leaving anybody out. Now I know I'm leaving some of the guys out that have the scopes that I don't have, and even the Auto because I'm not familiar with how to use it, but we'll work with the snap-on and the Picoscope for now. So my connections for this next test are battery plus and minus. I have channel 1 of both scopes connected to the battery. Channel 2, I don't remember which one I hooked up. I think channel 2 is connected to B plus of the starter, and then channel 3 is connected to the starter solenoid. We haven't actually watched the input from the starter solenoid yet. So that's another thing that you may have to hook onto if you're looking for a no start condition or a starter that's not behaving quite like it should. If it's engaging and kicking out before it should, you're going to want to look at that starter input and make sure that you're getting power to kick the starter in. And then my amp clamp is going to be on channel 4. Obviously, if you have a 1 or 2 channel Labscope, you may have to check each one of these things individually and analyze it and post up multiple waveforms. But really, if I was going to check the starting system alone, and I only had a 2-channel scope, I would hook up to the battery, and I would hook this around my positive battery or negative battery cable. It doesn't matter which cable you hook onto, because in a loop, the current's going to be the same at any point you can measure it. So wherever it's the easiest. A lot of times there's less stuff attached to the negative battery cable. Like on my Toyota right here that I'm working on, the negative is going to be easier for me to hook onto. We want to keep in mind that the amp clamp has a direction of current flow. So this clamp here, let me open that jaw up. See how it has an arrow pointing up towards me? That is the direction of conventional current flow. Conventional current flow is from the positive cable around to the negative. Now there's scientific current flow or electron flow that is from the negative to the positive. But most test procedures and documentation and stuff we have is based off of conventional current flow. So we want the positive, from the positive through the arrow and out towards the negative. So either way, if I'm on the negative, I just want the arrow pointing towards the negative cable end. If I'm on the positive, I want the arrow pointing away from the positive cable end. So I'm going to go ahead and hook around both my negative leads, because I have one that goes over to the fender and then one that goes down to the engine. Now this old Toyota pickup, it's a 95 Toyota pickup with 300,000 miles. Original cables, but it's a fairly small cable. It might only be a 6-gauge cable, and then it has the ground cable as well, and then there's a couple other grounds that connect to the engine from the body in various places. So I'm going to turn the amp clamp on. Always remember to turn it off when you're done, and then I'm going to point the arrow towards the negative battery post. So let's go ahead and set up both scopes. So on the snap-on, we're going to go to scope multimeter. Maybe, there we go. Labscope, 4-channel scope. Now, Snap-on doesn't have a preset for a high amp clamp. It has a preset for the low amp clamp, but not the high. And I'll unclip this again. This particular amp clamp, for every millivolt, for every amp that goes through here, it puts out a 1 millivolt voltage on the cable. So this kind of converts current flow into a voltage for us to read. And the scan tool is actually reading voltage. And if you're using the Picoscope, where it has predetermined or presets for you to select, and you pick 600 amp clamp. That clamp is the Picoscope still isn't measuring amperage. It's measuring voltage from the amp clamp, converting it into amperage on the screen, just so it's easier to understand. Since we're using the snap-on scope, we don't have presets and we don't have those or custom probes we can set up to tell it that. Let me turn off my cursors. We need all of our channels, so 1, 2, 3, and 4. Channel 1 is connected to battery, so we want 20 volts. Channel 2, I'm pretty sure, is connected to the B+ terminal at the starter, so that's going to be 20 volts as well. Channel 3 is the starter solenoid command. Now that is a 12 volt operated device, so we need to go to 20 volts because we don't have a 12 volt scale, and sometimes we would exceed that, so 20 volts. And then on this truck, I don't expect to see over 500 amps of power going through this, but we could go to 1,000 amps just to be safe, but I think I'll just set it at 500. On that first initial kick in, we may exceed that value, but setting it to 500 will let us measure the after current after the engine starts rolling a little bit easier. So 500 amps maximum. Now, one thing we do want to do is zero our amp clamp. Some of them have a button you can push and it'll zero it. This one does not. So I'm actually going to drop down to 100 amps and change my display here to where it shows me live data. And it shows that I currently have 8.4 amps going through that amp clamp. But I shouldn't. It should be at 0. So I'm going to adjust the knob just slightly here. This one has a manual adjustment till we get close to 0. Kind of bouncing back and forth, but that's close enough. What's a half an amp when we're measuring 500 amps? That's a pretty small amount. So now let me change my setting back up to 500 amps. And I know I'm saying amps and I'm showing you millivolts. That's because 1 amp equals 1 millivolt. Now, there's a couple other things that I want to include here. If we want to really see the solenoid activation, we may have to speed up our scanner or our capture. So for the snap-on, let's go to 100 milliseconds. We could probably see it on 200, but just to be safe, let's jump to 100. Keep in mind, this is also going to limit how much overall time we have on the screen. So you got to make sure to come out here and hit the stop button as quickly as possible. And then I'm going to turn peak detect on for the amp clamp. It's going to introduce a little more noise. But it may make it to where we can see a few more details on that circuit. Let me set up the Picoscope as well. So channel 1 is going to be 20 volts. Channel 2 is going to be 20 volts. Channel 3 is going to be 20 volts. Channel 4 is going to be... Now, since Picoscope I can zoom in afterwards, I'm going to go ahead and do that to a full volt so we can show the complete waveform. And then, how much time do we want on the screen? Well, since we have the ability to zoom in, I think I'll do 2 seconds per division. That's going to give us 20 seconds on the screen. And although we may lose a little bit of information, it may be a little grainy if we zoom in a lot. I like doing that just so I can see the big picture and zoom in a little bit closer. Depending on what scope you have, you can turn up how many samples you're collecting. And then I'm also going to turn a trigger on this one. We haven't talked about triggers yet, but in the Picoscope, I'm going to do a repeat trigger, and I'm going to do it on my amp clamp, channel D. And remember, we're on a voltage scale. So if I want to do 100 amps, so when that solenoid kicks in and the starter starts turning 100 amps, that's going to be 0.100, right? So 0.1 volts equals 100 millivolts, which is 100 amps. And I also don't like my waveform to start in the middle of the screen. I like to start it on the left-hand side. So I normally bump that over to the 10% mark. And now we are ready. Hopefully everything works fine. We can go ahead and start the truck up and shut it off. We don't really need to look at the charging data on this capture. We're just focusing on the last little bit of the starter. So I'm going to hit record. Both of them are ready to go. I'm going to start it up. Now, if you were having an intermittent problem, you may do multiple startups. Let me shut my door. The annoying buzzer going off. But for this vehicle, I don't have a problem with the starter, or I haven't really. When it's really cold, the starter stays engaged, so, but I think that's a contact issue. But if you were having an issue, you might do multiple startups. Every once in a while, these Toyotas, the contacts go bad and they just go click, click, click. So that's when you would have everything set up and just go crank off, crank off, crank off. Every once in a while, let it run and clear itself out. But if you're looking for that starter to fail, then that might be one way to do it. Otherwise, get a starter button and manually activate the starter over and over again to duplicate that failure without pumping a bunch of fuel. So I'm going to zoom out with the snap-on scanner, and I'm going to go back a screen on the Pico. Okay, so we got all kinds of noise. What's going on here? All kinds of noise on both screens. Okay. So it's not just one scope. I'm going to zoom in a little bit, zoom back out. Oh, it's because I turned peak detect on. Maybe I shouldn't have done that. Let's do it again with peak detect turned off. So we're going to try it with peak detect turned off because we had lots of noise on there. I don't know if maybe that is my starter failing because it shows up on the Picoscope as well. I'm going to take one more capture and we'll analyze it. Hit our stop button, zoom out. Now keep in mind these waveforms might look a little different in the time category because I didn't set the Picoscope to start recording again. Move my cursor over there. I'm going to zoom in about halfway. Move it again to where the starter first kicks in. Zoom in the rest of the way, and I'm going to get my settings out of the way so we can see what we're looking at. Move that kind of off the screen. And even after the capture, we can turn channels on and off. If we're looking at this and we're like, okay, well, I don't really know what's going on here. I got a lot of information on the screen. I can't quite see everything. We could turn off some channels. So let me zoom back out just a little bit and line up channel 1 and 3. Now these will almost mirror each other when the starter is engaged because my blue channel is the starter solenoid. That's not going to have power all the time. It's only when I'm in the crank position I have the clutch pushed in. So on this one, it gets a little power, and I can zoom in here, and then the starter starts spinning and our voltage drops. So that's why, even though you'd think that, okay, it's going to be an on-off signal for my key, that's why it has the same pattern as the battery, because it's getting fed from the battery. So if we zoom back in to that first point, move that back out of the way, we can kind of see right here where the blue kicks in before the yellow drops. Let me zoom in the rest of the way. And so our blue kicks in, that's the starter solenoid. That's my energize to the starter solenoid. And it has to move, it has to physically move and engage that starter gear into the flywheel and engage the contacts before it starts spinning. So it has to do a little bit of work. And then it starts spinning. My battery voltage drops quite a bit. It drops a little bit when the solenoid kicks in, but it drops a lot once that engine starts spinning over. And then at the very beginning of our waveform, we can see, our amperage jumped up a little bit. That was that solenoid kicking in. And then when it first made contact, and there's a little bit of a hiccup there, a little bit of a glitch, which is probably my starter contacts, where the amperage went up and then back down and then back up again as it started spinning over. So there was a hiccup in these starter contacts for a split second, which may be an early indication of a problem that I'm going to have. Okay, so let's jump over to the Picoscope, and remember, we can't zoom out with the Picoscope, but we can zoom back in. So I'm just going to grab the zoom tool up here. With the touch screen, I can pinch and zoom, but I find it easier to zoom in like this first. And also with the Pico, we can activate filtering after the capture's been taken if we want to clean up some of this noise. Now that starter does seem like it's pretty noisy, and that's on my amperage trace. I'm going to go ahead and just clean it up a little bit. So by clicking on channel D, I could activate filtering, and that's 1 kHz, so 1,000 hertz, and that really cleaned it up. So let's zoom in here and shrink that down a little bit. Spread my channels out. So this is our amperage that we're looking at here on the yellow trace. The green trace on this one, I should probably change my channel labels to where they both match each other, but green trace is my solenoid command, and we see that that jumps up, and then it sits there for a little bit. The voltage drops slightly as it's engaged, but we don't see any amperage until over here, and that's when it engages the contacts. Let me zoom in on that one section right there. Now, we have tons of detail here. We can zoom in, and even though we are taking 20 seconds of information on the screen, we can zoom into these fine details. And what I'm seeing here is the contacts are starting to make contact, but not good contact. We see a little bit of amperage rise as the voltage drops down. Now, the only way to verify this is if I could get on that other side of the solenoid to the actual starter motor power feed and measure it there, because that's going to tell us if we're getting power through the solenoid to the starter. But not every starter is capable of doing that. Some of them, the solenoid's built in and you can't get to that backside, especially like on the Hondas. But after looking at this, I still think that I have a starter contact issue. I'm going to zoom out just a little bit. And you don't always have to go all the way zoomed back out. You can zoom in and out using these buttons here, up here at the top. Or if I was zoomed out here to where I can see the whole picture, and I'm like, well, I want to look at that point right there. But then I want to go back to that spot where I was zoomed out. There's a undo button right here, undo zoom, so I can go right back to that point. Let me zoom out just a little bit further. And I just want the area here with our starter information. Actually, that has my charging information as well. So if we go here, there we go. Now, one other thing that I wasn't sure about, and I figured I'd check it now before letting you guys go with it, is the starter solenoid. I normally don't hook an attenuator up to the starter solenoid, so I wasn't sure if we were going to have that big voltage kickback like we do on a regular relay or a injector or coil, but it looks like it's pretty minimal. I mean, I don't have all the information here because it cut it off, and we went to -20. If you feel more comfortable with an attenuator on there, then you can go ahead and put one on there. But I don't think that we have quite the kickback on the starter. And then as you can see, we have kind of matching waveforms. They all overlap. They all look the same. And that's because they're all based off that battery voltage, which drops when we're cranking. So I want to measure the amperage of when the engine's actually turning over. That first initial amperage may be more than I want to measure because the engine's still sitting still. It has to get it going, and it takes a lot of energy to do that. But at that point, we're at 430 amps. To actually get the engine, or to keep the engine spinning, once it's spinning, we're only using 150 amps, and that's pretty typical. A 4-cylinder engine typically is like 100 to 150. A 6-cylinder is like 140 to 200. V8 might be like 175 to 250. And if it's a diesel, then I'll put a capture up on the screen of my 7.3 liter engine. It took like 450 amps. Well, it was fluctuating between 450 and 600 amps to keep that engine spinning once it gets started. That's why those trucks have 2 batteries, and the cable connections are so important because they take so much energy to spin those engines. Now, in this waveform here, let me zoom in. Okay, see this amperage right here? Around 40 amps. So right there, where we had 40 amps of current draw, that's the amount of power that starter solenoid took to engage. Now, that starter solenoid has 2 coils inside it, a pull-in coil or pull-in winding and a hold-in winding. When you first crank it over, both of them get power. And then once the starter solenoid makes contact, the pull-in winding gets cut off. The power gets cut off to that one, internal of the starter. And I can explain that in another video, how starters work and the details inside of there. But about 40 amps to get that solenoid to kick in. Now, same with the snap-on. We can see that on here as well. Let's turn our cursors on. And that is this region right here where I'm kind of sweeping that back and forth. And if we make it to where we can see our measurements, cursor number 1, 44 amps. So we're seeing the same information. Now keep in mind the captures look a little different because it was a different starting cycle. And then another thing we can do with these cursors is we can measure how long that solenoid took to engage. Now there's no spec for this, but you know, just because we haven't measured a time base with the cursors, we can demonstrate that now. So with those two cursors, the one when I first applied power to the solenoid with the key, and when the starter solenoid actually made physical contact and started applying power to the starter motor, it took 24 milliseconds between those two cursors. We can do the same thing with the Picoscope. Now keep in mind the time frame may be slightly off since it was a different start cycle. It says 23 milliseconds. So that seems like quite a bit of length of time for that solenoid to actually energize, and that's because it's a heavy solenoid. It has to move quite a bit of distance. It has to engage that starter, and it takes some time to do that. A typical injector is only going to pulse for 1.5 to 5 milliseconds depending on the throttle position. So 23 milliseconds is a long time. So after this, that's pretty much everything you need to or can scope on the starter. Now some vehicles, if you can get to the other side of the starter solenoid, great, connect to that. It'll give you a little more data, especially in this case. I wish I could connect to that because that might tell me if I'm breaking contact with the starter contacts or what's going on when it's really cold out and I go to crank it and that starter stays engaged for an extra second after the engine's running and I let the key off. You can hear the starter kind of and then it winds down. So that might give me a little more information, but I have a feeling that the starter contacts are worn out and it's actually holding that starter engaged. So if you don't have a high amp clamp, I have the Picoscope one, the Fluke one. I think I have a PDI unit as well. The inexpensive high amp clamps are normally pretty decent. Since we're not measuring vast amounts of accuracy, we're very rarely calculating Ohm's law with the amp clamp. It should be perfectly fine to buy an inexpensive one. Now, some of them don't have shielding in the cabling, so if it doesn't have shielding, you might pick up a little more noise from the lights and the power lines and even stuff in the engine bay. But for the most part, if you buy a good one, it's going to last forever. This one here is my father's. I don't know how old this thing is, but it's still in perfect working order. Luckily, nobody's dropped it or had the cord get sucked into the fan blades. If you guys have any questions on the starting system, everything we've tested up to this point, put it down below. Other than that, we'll move away from the starting system and move into some other testing. I know if you guys are new to this, it still might be a little overwhelming. For you guys that are a little more experienced, you're like, yeah, come on, let's get past the starting charging system. But I want to make sure everybody's comfortable with what we're at and what we're doing before we move on. So if you're not a member of our Facebook group already, there's a link down below. It's called the Automotive Weekly Waveforms. Every week I post up a video like this, and in the Facebook group you guys can do this test on your own throughout the week. Post a picture up of the vehicle, whether it's a known good or a known bad, it doesn't matter. I much rather test a lot of known good vehicles. That way I know when I connect to a known bad vehicle, if the waveform looks different, I can recognize that, and then I can say, why is the waveform different? What do I have going on here? I can analyze it. But you want to know what a known good waveform looks like before you start chasing the known bads. So remember, that link is down below. If you want to follow this series, make sure you subscribe and click the bell. Questions, comments, put those down below. Thanks for watching, and I'll see you next time. And remember, turn off the amp clamp.